All right, I wanted to go over just a few problems on this page, just in case we have issues with some of them. So I think that number one is well within your capabilities of doing. We'll do one that's a little bit that's similar to that, but a little bit more difficult. So if you look down at number two, first I'm going to go ahead and rewrite this using dy dx. I've got x plus y. And remember, the goal of a separable differential equation is to get all the x's on one side, all the y's on the other side. So here, if you think about how this would work, I would have to multiply the right side by dx to get the dx to the right side. And then that dx would apply to this x, but it would also apply to that y. So then I would have x's and y's on the right side. And then for me to move this y over to the other side, I would kind of have to divide by y. There's no way for me to separate the x's and the y's completely in this problem. And the reason I cannot do that is because the only way for me to move the y to the other side is to add or subtract it. And differential equations are only separable if you are multiplying or dividing that y to the other side to move it. All right, so here we're going to say that this is not separable. And that's because there's no way for us to move the x and the y to either side by multiplying or dividing them individually. You'd have to add or subtract them, and that does not make for a separable differential equation. Now, if we look at number four and number one are actually fairly similar, so I'm going to go ahead and rewrite this to start with. I have dy dx equals ln x plus x over ln y plus y. So here, I have to think about what I could do to get the x's to one side and the y's to one side, and what you'll notice is that this whole group is in terms of x's and this whole group is in terms of y's, and that's a good sign because I can take this whole group and move it to the other side by multiplying, and that's a valid thing for me to do. So there's two different ways to think about it. If you look at this problem and you want to say a fraction equals a fraction, so you want to cross multiply those, you are certainly welcome to do that. The other way to think of it is to say, like, I want to get this dx off the bottom, so I'm going to multiply that to this side, and then I'd have a dx over here, and then I want to get this off the bottom, so I'd multiply it to that side, and then the ln y plus y would be on the left. So we're going to end up with ln y plus y dy equals ln x plus x dx. And this is a separable differential equation because I was able to get all the y's on one side and all the x's on the other. Number five, I think if you look at this one, it looks really tricky because it's got the trig functions, but also because it's got that exponent. So we're going to go ahead and rewrite this so you can see a good way to think of a problem like this. You have to remember your exponential rules. So if you recall, if we had like x squared times x to the fifth, you guys would look at that and say, oh, that's x to the seventh. And to do that, you added your exponents together. So if we look at a problem like this and I can see that my exponents are added together, that means that it was really e to the sine x times e to the cos y. And this right here is actually considered to be factored form because you've broken it down to different things that have been multiplied together. So these are the factors of this product right here. These are the different factors. So I'm not going to do this problem for you, but this one is separable. It is possible to get your x's to one side and your y's to the other side. Okay. On this one, I'm going to give you a little hint. If you guys recall the properties of logarithms, anytime you have an exponent with a logarithm, you can move it to the front. So number 6 is a separable equation, differential equation. You can separate those. Okay. We're going to go ahead and bounce down to number 9. Number 9 is one that can be a little bit tricky. So what I did when I started number 9 is I just kind of went through and I said, well, I can see that the top should factor and I can see that the bottom should factor. So on the top, I took out a GCF of y, and that gave me x plus 1. And on the bottom, I took out a GCF of x, and that gave me 2 minus 3y. And then I knew I wanted to think of this as the product of something that has to do with x's and the product of something that has to do with y's. So what I did is I rewrote this problem so that I was thinking of this as being one fraction, so x plus 1 over x times, and this as being another fraction, so that'd be y over 2 minus 3y. So here I was able to kind of, again, this is factoring because I'm thinking about two things that multiply together to give me something else. So this is factored form. And I was able to separate my x's from my y's, which means that this is a separable equation. I will be able to get my y's all to one side and my x's all to the other side.